Hi, so something a bit different today. This is a laser unit from a Tornado jet fighter. This is used for, I believe, bomb targeting and range finding. And interesting story about this. Many years ago, I think before I was even doing YouTube, I bid on one of these on eBay and won it. And the next day I got a phone call from the seller saying that he was a bit embarrassed that they'd had a visit from the Ministry of Defence, and apparently he wasn't supposed to have this, so he couldn't ship it. But they seem to be a little bit more available now. Also, when I got this about a week ago, I sort of tweeted a picture, and someone actually sent a link to another YouTube channel, a French guy called Michel, Mike, coincidentally, who's done a lot of military electronics teardowns, and he's also done a teardown of this and actually gone into quite a lot of detail, reverse engineering stuff, getting some of the motors and the laser actually running. So I'll link to his videos down below because there's some more information. He found some technical information about the actual laser and how that worked. So I'm not going to sort of repeat that, but I'll probably sort of tear a bit further into the optics and some of the other details on this, but say the other videos are definitely worth. I think there's about 7 or 8 videos in that series. It goes into a lot of detail on this. And the front you can see sort of this glass dome and this nice sort of gimbal mount optics assembly. You can see it sort of moves around if you sort of very free moving assembly. On the side we've got the cooling system. We've got like an air path that goes through here, an air to liquid heat exchanger. I've taken off the pipes because I drained all the coolant out. There's a couple of tubes that go to the back here, like an in-out circuit and a pump. And there's also an air circuit that cools, there's a sort of internal fan that sort of runs some air through here, and a second heat exchanger down here. This dates from late 70s, early 80s. There's various date stamps on different parts ranging from 1979 to 1984. But obviously, if it's all manufactured then, the design probably goes back at least probably 10 years before that. Backside here we've got this rather corroded connector. This was going to the pump motor. I think it's maybe a coolant leak because the signs of sort of rust and corrosion around some of the places on here. I think this top port is for pressurization. I think the entire inside was probably pressurized, maybe with nitrogen, to keep any sort of moisture out. There's these 4 multi-pin connectors on the back, so this I'm sure would have been connected to one or more boxes or the control electronics, and say because of the date, a lot of this would have been very analog, things like synchro resolvers. So this liquid cooling unit just sort of screws onto the side, and there's this, I think this is probably some sort of pressure regulation and reservoir type thing. The pump on here is 200 volt 3-phase 400 hertz motor. 400 hertz is very common on aircraft, and we see the heat exchanger part there, and with that off we can see this air-to-air heat exchanger for the internal air path, and this is all held together by a couple of these clamping rings. You can see the profile there, so as this is clamped down it pushes the 2 parts together, so after that's come off this whole assembly slides out. And the top we can see the optical assembly, which is got these beautiful sort of super smooth bearings. Yeah, the tiniest touch will get this sort of moving very, very nicely. This moves on 3 axes. We've got sort of that way, and there's also a rotation. I suspect the reason they've done this, because in principle all you need is 2 axes, but I think again because of the sort of vintage of this, it's probably analog controls which are designed to work directly off, say, an aircraft gyro or something. So, although in principle you can get pretty much any direction, I think in practice what they do is they just match the axes to the roll, pitch and yaw of the aircraft. There seems to be, I'm not sure if there's a motor on each side or there's 1 motor and 1 sensor for position. They are different colours, a red and a black on each of these 2 axes. I'm not sure how easy this is to see on camera. It's a bit in the centre. We've got the output from the laser that comes up sort of from inside, an arrangement of prisms that sort of bounds it sideways and across, and that then comes out of this lens here. And then at the back we've got a sort of parabolic mirror with a hole in the middle for that laser to go through the centre, and that then comes up towards this sensor. And based on some of the information in those other videos I mentioned, I think there's also a beam splitter in here that takes it sort of forward to one sensor and backwards to another sensor. I think there's a 4-quadrant sensor for positional sensing on one side and a sensor for range finding on the other. This is all like super smooth and super expensive looking. Typical military stuff, and we've got the classic military sort of assembly techniques of sort of bundles of wires very tightly wound with sort of cotton thread type material, which is sort of thread along knotted to give a sort of rigid bundle. And quite a lot of the wiring is done in sort of enamelled copper, presumably just to save size and weight. And from the side view, pretty much everything is mounted in a sort of shock. There's like a shock mounting. There's like an internal structure here, which has some mechanical isolation from the outer shell. We've got this fan, which again is sort of super smooth, just a slight touch, and it just carries on spinning for ages. And we can see one of the shock mounts here. I mean, there's very little sort of obvious movement here, so I think this must be mainly for like high frequency vibration, because I can't really feel much sort of give in that. Okay, after some difficulty, I've got the outer layer of casing off this thing. There's all sorts of hard to get at screws and things. These shock mounts, they're sort of spring with this sort of wire wool type damper arrangement. Quite a lot of these shims sort of fell out all over the place when I took this out. So it must have been quite interesting to assemble in the first place. So you can see a little bit more of the electronics here, some high voltage stuff, a few little bits of analog, sort of discrete components here. And just in here we can see a big, I think it's either a diode or a thyristor. This is a flash lamp pumped neodymium YAG laser, so a lot of this will be to do with running the flash tube. On the back we've got all these very multi-pin connectors. All interesting, this one is actually being used as not that many pins. They've got a lot of pins wired in parallel, just a little PCB on the side, and some sort of fairly chunky wiring, so that's probably just to beef up the current capability while keeping the cable fairly flexible. Pulse forming network on the side. I don't know whether that's internal to this or just these external parts to make this assembly. That sort of pulse forming networks tend to be a combination of inductance and capacitance to sort of shape the rise and fall times of an edge. Because on something like this, you probably want to control the rise and fall times to the of the flash tube current, just to control the length of the pulse. And here's what looks like a little high voltage vacuum relay. There's a date stamp here, 11th Jan 84, JANV, which sort of suggests some French involvement from sort of Janvier. The manufacturer of this is Ferranti, who are, I believe, a UK manufacturer, but maybe some of these parts are manufactured in France, or they subcontracted the mechanical parts out to a French company, perhaps. Here we can see how they transmit the wires across the rotating joint. It's just a number of turns of this ribbon cable. There's like a sort of low density one, presumably for the higher current stuff, and then this higher density stuff for all the other bits. And there's about I think it's about 3 or 4 turns of this. This has only got about half a turn degree of freedom, so having sort of multiple wraps of this means there's very little stress on the wires as this rotates. Right, I've separated the optics and laser assembly to make it a bit less unwieldy. This thing, which I thought this was high current stuff, is actually shielded stuff. This connector goes up to the front through that flex up to the optical sensor at the front, so a lot of these are shields. You can just about see there's a sort of ground plane on here, the wires pass through, and then there's sort of twisted pairs coming through there down onto the actual pins. So this ribbon here, these are actually all shielded twisted pairs going to these little cute little micro D connectors. Speaking of connectors, interesting, in some places they're using these mixed contact D connectors, but not actually using these coax contacts. So I'm not quite sure why they do that, unless it's just they had the parts in the inventory and didn't want to change. But it's a bit odd that they're using those where it's just, I mean, that one could just be like a simple 9-way D, unless there's maybe some different versions, perhaps it's used in different versions, they want to maintain some compatibility in connectors. But on top of here we've got various high voltage stuff, some slightly curious construction here. It's just sort of bored with turret tags and sort of wired in between. I don't quite know why they wouldn't use a PCB here. Obviously it's high voltage, so they want the clearance, but seems a slightly bizarre way of making it. There's a big high voltage cap here. This is 0.25 microfarads at 3 kV. Interesting, it's got some interesting, I think Paxilin or something similar for these little end caps. Under here's another board, just some diodes, capacitors, some resistive stuff. I'm guessing this is probably a transformer here. probably the supply for the flash lamp. Under here, some sort of big mounting bracket just for this stuff. I suppose this transformer's quite heavy, so it needs some fairly solid mounting. It's a big bunch of power resistors. There's a big thyristor here, which from the other video, that's actually in series with the tube, so that's to do with controlling when the tube gets connected to the flash capacitor. Just a few other just random discrete components on here. Obviously, almost all the electronics are located in the the box somewhere else in the aircraft, so this is just the absolute minimum needed to that actually needs to be located close to the bits that it's controlling. Now, I thought these were just enamelled wires, but obviously thinking about it doesn't really make sense because they wouldn't have had very good vibration resistance. They're actually stranded, but with extremely thin coating. I'm not quite sure what that is. It looks like perhaps Kapton or something, but obviously this gives sort of very high density for something like this, and fairly low, presumably fairly low weight because you've not got the weight of the insulation. Obviously they do use other more conventional wires here, but this I think is all for high voltage. Of course, you need the insulation, and this feels like feels like really smooth. It might be PTFE or something. Now this assembly at the end, so the label's pulse forming network. Now I'm not sure if pulse forming network applies to sort of just this part or the whole assembly. As far as I can see, this just looks like a capacitor. It measures about 20 microfarads as per the rating. Obviously you've got these high voltage standoffs here. There's this vacuum relay. And this is a 50 microhenry inductor. We've got a high voltage rectifier here. Some resistors. I suspect these might be bleed resistors. Interesting, they're actually mounted on aluminium in insulating standoffs, whereas everything else is done on sort of PCB material with standoffs there. There's high value resistors here. That's pretty monitoring the voltage. These are all sort of several meg resistors here. So this is probably shaping the discharge for the flash tube to optimise the amount of energy. Right, the laser module comes out of this section fairly easily. Not that many connections into this. So you've got the two coolant tubes there. So high voltage connection here. Some sort of connections down into the main. Some feed through connections here. That I suspect is probably a monitoring photodiode to measure the light output. Laser resonator assembly 1984, and this cage is mostly just sort of cable management. There's channels each side to run up to where those ribbon cables are, and they just go straight to the some connectors on the back. A little shielded box down here that seems to just contain a board with two capacitors and a couple of multi-turn trimmers. So these two devices here, which I suspect are probably thermal sensors or thermal cutouts. This one goes through this sort of. I just noticed this box has got a label control gyro scale, so that's obviously some sort of scaling adjustment for something. I can't quite see that. That's worn off, but it's 1970 something, so it's quite a lot earlier than the rest of it. Okay, so this is inside the laser head. As I said, Michel's video has some details that he found in a book. I'll also link that down below, which shows pretty much the exact same system. So I'm not going to go into too much detail there, but it's basically the this is the trigger transformer for the flash tube, and that's connected to this metal body. This whole thing is mounted on an insulated support. So that produces the high voltage pulse to fire the tube. This block I'm guessing is some sort of pulse forming network or transformer to drive the Qswitch. The idea of a Qswitch is that it blocks the laser cavity, so the flash tube pumps the energy up into the YAG rod. And then the Qswitch opens once the energy is built up to the maximum to allow very fast pulse out. And some figures in that book quote a 20 nanosecond pulse at 100 millijoules of energy, which is about a 5 megawatt peak power output pulse, which is pretty impressive. Beam takes like 4 passes through this cavity, obviously just to reduce the size. There's various prisms in here, so it goes sort of through the rod, reflected down this prism in the corner, down reflected back here into this prism, then back, then across here through some optics through the Qswitch, and then back, and it's reflected back through this prism. So it's sort of all the optics have been folded down to make this a very compact unit. So this is the Qswitch. It looks like some sort of acousto-optical type device, maybe perhaps a Optical cell or a Kerr cell. I don't really know enough about these to comment, but it looks like it's just sort of transparent material with electrodes on each side. Stuff written on the side, but looks like it might be some boundaries there, so I think it might be multiple materials, but say this changes its optical properties based on some electrical stimulation. This driver module, looking at the X-ray, it looks like there's a sort of couple of toroidal inductors and a transistor in there, so that's presumably sort of producing some sort of voltage, maybe a particular frequency. I know some of these devices sort of work on fairly high frequency RF, but it's a bit hard to tell really what that's doing. And the trigger transformer, you can see there's you can actually see the trigger coil on the X-ray, and also what I would presume is a thyristor and a capacitor to produce a high voltage pulse to strike the tube. Right, this is the actual laser cavity. The coolant is actually flowed through here, so I presume it's a fairly non-conductive coolant. I don't think it's insulated from the high voltage tube connections. Just a sealing O-ring here, so this whole thing is full of coolant when it's running. You can see a reflector here, very highly polished. So I think this forms like a sort of dual ellipse, so it's basically focusing an image of the flash tube to the centre of the YAG rod. There's a piece of glass, or yeah, the plastic or glass between the tube and the YAG rod. It doesn't seem to be for sealing, sort of for coolant, because there's no sort of seal on there. So I wonder if maybe this is doing some sort of optical filtering. Yeah, it's glass rather than plastic. I can only assume, I can't think what else that would be other than some filtering, perhaps filtering out the infrared or some group of wavelengths from the flash tube. And there's also a similar profile underneath, so it's sort of focusing all the energy towards the rod from the flash tube. So this is the actual flash tube. I don't know if this is like a standard xenon tube or whether they've sort of tuned the mixture to get exactly the right wavelength for the optimum pumping of the rod. There are actually sort of O-ring seals at each end, so that the coolant rod, the tube and the rod are immersed in coolant, but there's a seal between there and the high voltage. So I thought it was a bit odd that I was wrong earlier on. So it's just the tube and the actual glass of the tube that's immersed in coolant. So there's these O-ring seals at the ends that are just compressed by these insulating supports, so the coolant doesn't need to be insulating. And this is the actual lasing rod. Obviously it's got very highly polished ends, very slight purple tint for the doping. So it's neodymium YAG, I believe. So with the actual laser cavity out of the way, we can see a little bit more in here. Just sort of a big collection of prisms. So there's a prism there that makes it sort of go downstairs, across, back, and then sort of across. That does like a little loop back there, and then back up to this level. You see the sort of two levels of prisms in there. And in the front there's this adjustable mount, which when the screw slackened off, this can be moved sort of up, down, left, right to direct the output beam in the right direction. Okay, now let's take a look at this optical head. Right, so this is from the back. This is sort of the rotation axis. You can see there's this ring, this large gear here. And we've got 3 units on here. 2 of these are identical. These are marked as servo motors, which have a 40-to-1 gearbox. And there's a like a synchro resolver, which I've covered before on some of my military teardown, which is basically a position sensor. And this is geared down, and these are anti-backlash gears. The actual gear itself is split into 2, and there's like a spring between them, so the teeth actively grip to avoid any backlash when it changes direction. And I'm not quite sure why there's 2 motors. It could be just to get enough torque. They're used in parallel. Or it might be that they're driven from 2 places, because these will be designed to be run from a synchro resolver type input, so it may well be that they can get their direction from 2 different places and it switches between the 2 or something like that, but I don't really know. On the front we've got this optical receiver assembly. A little bit of electronics here. This is presumably the preamp for the sensitive signal from a what I imagine is probably a photodiode receiver. And under this cover looks like we've got some hybrid modules of some sort. And then this lifts up and this looks like the back of the photodiode assembly. So next layer down is this assembly. Interestingly, there's a sort of feed through here which has got a wire connected to the outside, but there's actually nothing connected inside. So I don't know what's going on there. And if we lift this up, we see this absolutely colossal photodiode detector. We just about make out it's split into 4 quadrants, so this is obviously detecting position, and I suspect these 4 modules are probably one amplifier for each quadrant. We'll take these modules apart in a minute. But that is probably the biggest photodiode I've ever seen. And there's just a spacer here, and then this, I'm certain this is going to be a narrowband infrared filter, so the optic system's only seeing the wavelength that the laser's transmitting at. It looks sort of pretty much opaque, and if I shine a really bright light through it, you can just about see a sort of slightly red image of this LED torch, but it's very, very opaque at visible wavelengths. And on the other side, you see this. There's a piece of glass here which I think is a beam splitter, and it's reflecting some of the signal to this. I think this is the receiver used for time of flight distance measurement. So it looks like there's a little enclosure here that's probably got some electronics for this sensor. So I think this is just a beam splitter plate. There's a little arrow on the edge, so I'm guessing there's probably some sort of coating on there to give it the right amount of reflectivity at the 1064 laser wavelength. And this is that other sensor, and again looks like it's got an infrared pass filter on it to filter out everything except the laser wavelength. And inside we've got the amplifier electronics, the same, looks like it's the same amplifier module that we saw in the front sensor. Some sort of custom chip or hybrid. And this is a more conventional looking photodiode. Obviously for time of flight it needs super fast response, so it's a very small device there. And this module's got sort of quad inline pins. There's usually this little wire there grounding the top cap. So let's pop this off and see what's inside. Well, this is interesting. Never really seen a hybrid like this. Looks like we've got sort of like a glass section at the top with resistive elements. These are bonded to the semiconductor devices. Looks like a mixture of 2 and 3 terminal devices on the bottom, and then some eye bonds to a few ceramic caps along the bottom edge. So you can just about see these sort of shiny sections. Actually there's another one at the bottom there, so we've got this top section which looks like just resistors, and then this bottom section with a few more resistors, and then the capacitors at the bottom. So obviously this was sort of pretty slightly before the days of hybrids with chips in them. So I've never seen that sort of construction before. I can't see any obvious signs of laser trimming on that glass bit, but it's hard to tell. But there's clearly resistive elements. Now these have got 1978 date codes on them by the looks of it, 3, and some sort of pencil marked sort of serial numbers on the back. These are probably from testing. A lot of these are connected in parallel. I'm guessing these are mostly sort of pretty power. These are probably mostly power and bias pins all connected in parallel. And here's the massive 4-quadrant photodiode. It's made by Centronic England, who are actually still around, still making photodiodes. It's a QD320 4E. It's got mounting studs on it, which you don't often see on this sort of package. Huge piece of silicon in there, good sort of 20 odd millimetre diameter. That receiver out of the way, you can get a better idea of how this laser optic prism assembly works. So the laser comes up here, gets bounced across onto this mirror. So for this axis, that's just like a rotation, so obviously as long as this is all perfectly lined up, that rotation won't make a difference to the position when it reaches this one. And there's sort of another prism sort of surface there and there, so the beam goes up and across and then in this direction, so that when it pivots this way, again the beam is central so that that rotation doesn't affect it. And there'll be another prism sort of in here to direct the beam up out of this lens. Okay, I can't really tell whether these motors or sensors or both. There seems to be a lot of wires coming from them. There's you see quite a lot of windings on the back side of them. These patches, these are just tape holding the these wires down into the into channels on this section. But there's about like 6 sets of 3 wires going in there somewhere. Quite a lot of pins on that connector. The red and black ones, as far as I can tell, look pretty similar, although the winding style is slightly different. If you look on this, it all looks a bit sort of random. Whereas this side, yeah, you can sort of clearly see the separate inner and outer windings sort of all bound up together. On this side, all the windings seem to rotate with the rotor. On that one, only the middle section, so perhaps possibly be inclined to guess this is maybe more of a synchro resolver type thing. You've got sort of 2 sets of windings moving in relation to each other, so it can measure. If we look through the side down, this floppy silicone wire, that's what's transmitting the wiring from the moving part to the static section. And the other thing you can see, on each axis there's one of these. I'm guessing this is some sort of gyro or accelerometer to provide some feedback. Okay, getting all this lot apart was an absolute nightmare. It's taken me about 2 hours to figure out how to get it apart. Each of these sections of the gimbals had sort of 2 of these sort of motor sensor units on them, and I just couldn't figure out how they were coupled. So yeah, this was sort of rotating on here, and I think obviously figured out there must be a way for these to come off for the whole thing to come out. Eventually, via the application of a bit of applied violence, I figured out that what you have to do is you rotate these to a specific point, which then reveals 3 Allen key screws that screw it into these. The problem is, on 3 out of the 4 of these, the heads of those screws have been chewed, presumably during assembly, so I couldn't actually get the Allen key into it to undo it. I eventually used some leverage to actually shear off one of them to figure out what the system was, and say the other ones that I couldn't undo I ended up having to drill out, so not very repair friendly. But so these are actually quite interesting. There are 2 different types. This one, which seems to just have sort of a single winding with sort of set of poles there, and this one I can't actually see, there's like the rotor here, but I can't actually see what the stator winding looks like. I think these use bearings that are pressed in. In addition to the motor and sensor functionality, they've also got like a sort of little roll of flex inside, so they act as sort of get some signal across the moving thing. Bear in mind, of course, these only move via a limited range, so all of these actually got this little flex thing in the middle, so there's wiring sort of going across all 4 of these rotation points to various, either to like the next one in, the next system in from the outer thing. So obviously that's sort of the first one. Then we've got the sort of one of the tilt roll axes, and then we've got the next one here. Now look at this one very closely. It looks like some sort of copper structure around the outside, and there are sort of, I think, some sort of pole pieces that these coils are wound around. It's a bit hard to see, but there's definitely something around the outside, so I wonder if that's actually sort of maybe an induction motor, and this bit around the outside is what you normally sort of traditionally have as the rotor on an induction motor. But to be honest, I still can't really be certain which of the... Yeah, I'm pretty sure that one of these is a motor and one's a sensor, but I'm really not that sure which is which, to be honest. So this flexible wire that I saw earlier, this is the signal connection to the sensors. Obviously, these are sort of shielded wires with like ridiculously thin cores. Don't think I've ever seen sort of plastic insulated wire this thin ever. It's 0.3mm outer diameter wire, crazily small things. Obviously they don't want to put those through the flex things, obviously, yeah, just because they want a nice low level signal protected from any noise. So if they'd have gone through the flexes on those motor hubs, they'd have probably been subjected to quite a lot of noise. So there's 6 shielded connections for the sensor stuff there. And finally this. There's 2 of these mounted at right angles on here, and these are gyroscopes. Smith's micro miniature rate gyro, and you can get a sort of rough idea of what's going on here. We've got 3 phases here, which are for a motor. This is sort of like a transformer arrangement where the coupling varies by a mechanical signal. If we open this up, what we see is rather amazing. So this is a gyroscope, and then this is the rotation that it detects. So we've got this sort of motor-like structure here, and then this sort of coupler. So the position of this produces different coupling across the windings of this transformer. So this spins up to whatever it speeds to need to do its gyroscope things. Obviously some sort of precision bearings at each end. Unfortunately the wire snapped off when I was taking this apart. Beautiful engineering going on there. So all these little marks where they've drilled it to balance it. But that is rather cute. Now I was wondering how this gets around the problem of powering this through the fact obviously this can rotate, and that's what it's measuring. This is powered by these tiny little wires that connect onto these solder pads here. I think what it is, there's a slot here and there's a pin in the end. So I think this can only actually rotate over a very small amount, like literally about sort of that much, the width of the pin in that slot. So there's no problem with those wires. So this is sort of clearly just measuring over a very small range of rotation. So it's a very nice smooth bearing there. So that's a pretty interesting collection of electronics, mechanics and optics, sort of heavy duty military construction. I'm sure there's probably people out there that know a bit more from the history and military side of things. Please add anything in the comments that you know about this, and I wonder if any of these are actually still flying. And so back in late 70s, this must have been fairly state-of-the-art tech, certainly in terms of military, the sort of timelines of military stuff. And so as far as I can tell, this is primarily used for basically illuminating a target so that a missile can then home in on it. So all this sort of gyro stabilisation was so that you could actually aim the laser at a target on the ground and it would actually stay in one place regardless of the movements of the plane. Interesting stuff. It makes you wonder sort of what today's military tech's like, although the development timelines are still sort of pretty long, so I'd imagine even the stuff that's flying today is a good few years out of date with the rate of the pace of sort of tech evolving. So I'd be interested to know, of course that's all still somewhat top secret, so maybe in 10 or 20 years time we might get some teardown items for some stuff that's flying today.